Okay, so we're going to try to find a power series for 1 over x centered at x equals 1, and this being centered at x equals 1 is kind of a big deal. So what that means is that I really need to have an x minus 1 in my denominator, but I also need a 1 minus. So first thing I'm going to do is say, I really wish that I had an x minus 1. But I'm not allowed to just put an x minus 1 because that changes the whole problem. So I'm actually just going to add 0. So, right, that's going to be sort of in the form that I want it, but I'm going to turn it around so that I can put my x minus 1 in parentheses like this. Sorry. So just a little bit of algebraic manipulation, move that to the front, put that in parentheses because I'm anticipating that I need 1 over 1 minus something. And so now I'm going to change this into 1 over 1 minus an extra parenthesis, negative that thing, just kind of like what we did with the 2, I think it was last time, whatever it was. Negative, negative makes positive, so then finally I have this in the form of my cloud and my heart, and so I can say this sums up to 1 times negative x minus 1 to the n. And if you would rather, that's going to be negative 1 to the n from this negative to the n, and then x minus 1 to the n. So now it's an alternating series, but it's also geometric. And so since it's a geometric series, the interval of convergence will be when the absolute value of x minus 1 is less than 1, which gives us x minus 1 less than 1, greater than negative 1, add 1, add 1, add 1. Interval of convergence, 0 to 2. Do we check the endpoints?
No.
No. Done. Okay? So we're always trying to get it in that form because it's such a fun shortcut. And so this is a pretty overwhelming slide, but I just want to run through some of these theorems. I wonder, I should have just had you, actually, let me just have you fill these in from the textbook, honestly. I'm not going to write them. But it just says that if you, this is really important that we'll end up talking about later, and I'll call it Smart Girl, but this just says if you have a series that has, it's f of kx, but you have a series for f of x already, like you already have the series for f of x, I'm going to write it, I can't help myself. You just take the x out and you put in the kx, so this goes here. So you can substitute, and you already saw Busani do that earlier in a video. What did you substitute? You substituted negative x
for x.
Yeah. So if you had a 2x, you can put a 2x in where every x is. Or if you had a negative x, you can put that in where every x is. This is the same rule. You have x to the n. In my class, we yell capital letters. And so x to the n is going to be substituted in like that. It's basically just a substitution. It's super easy. This says you can add together two series if you want to by adding together their sigmas, but there's this little caveat right here that if you're looking for the interval of convergence, and like maybe you have an interval of convergence here of like negative 1 to 2, and an interval of convergence here of like 0 to 3, the interval of convergence of the sum of those two things is going to be their intersection. So what would the intersection be of those two?
Definitely 0 to 2.
Is this the symbol for intersection?
Yes.
Okay, so it's going to be the interval 0 to 2 for the answer to that sum. Okay, and that's kind of a rare thing. You won't really use that very much. And okay, so this is a pretty complicated example. I'm just going to throw a few words to it and then move on. This power series you can do with everything we're learning by factoring this and using partial fractions, and Busani's class probably calls it partial fractions, and my students call it Jim's rule, but it's like the cover-up method, and so you can write two different little fractiony things, and then you can find the sum of both of them as geometric series, which is what this is about, but I'm not going to do it. It takes a long time. We're going to skip it, but it's in the textbook. Okay.
Good.
Whoa, okay. Might this have something to do with the example that we just did?
I wonder.
The center of 1 over x. We had figured out that 1 over x was the same thing as negative 1 to the n, x minus 1 to the n. Is that correct?
Yes.
Is that what I just got? I need to check my notes, folks. I am not ready to be teaching all of chapter 9 on Friday, March 13th.
Woo.
Friday the 13th! I'm still pretending
Okay,
like
these guys
I
are
need to
logging
check.
in on like April. It's like
I
April
know.
8th right now.
I know, but well, okay, April 8th then. Okay, where am I? Did I have it right?
Yeah.
Okay, good. So then what would this have to do with that? You got this, Busani.
So if I want to change it to 1 over x minus 1, is that what you're saying?
No, this is a
Oh,
series
sorry.
that
So
approximates
I can
that,
take
and I'm
the,
looking for natural log.
correct, so I can take the integral of 1 over x to get the natural log.
I can. Okay, perfect. So then
But
this
Mrs. Speckle, what happens to the plus c when you integrate?
delete that. Didn't happen. We're not doing
We're not doing
We were not going to talk about that. Why are you putting me on the spot? I can't even know. I can't even integrate right now. I'm so nervous. Okay, so the series becomes negative 1 to the n, x minus 1 to the n plus 1 over n plus 1. Is that right? Did I do something wrong?
No, it's awesome.
This is a constant. It's not going to change as you do every term. And I'm going